Okay, hi guys. Prajit here. Can you guys turn on your webcams? I will start in a moment. One second. Okay. Starting. Hello. Hi, Amit. Hi, everybody. Yeah. I'm sorry, there was a technical delay, a delay because of a technical issue. My calendar wasn't updated for some reason, so uh, yeah, I was sleeping nicely, and then no, I wasn't sleeping. I was coding, and then I realized a little late about the class. So 1 second, we set up certain things on the screens here. Yeah, hi. Okay,
Yes, sir.
okay. Here we go. So we will start now. 1 second. So the issue is right now. So I won't be doing what is that? Electricity. I will continue onwards to what is that? Wait. I'll be continuing onwards to vectors. Can you see vectors? The PPT slide.
Yeah.
Yeah.
Awesome. So here's the thing. You guys have studied vectors here, right? Everyone, the good old online class. Yes. Hey, by the way, did you guys watch the crew to launch? It was at 3:45 roughly, 3:45ish today.
The helicopter.
I watched it live. It was fun. The usual rocket landings. They have needed it. Did you guys also watch the helicopter, the Mars
Yes.
helicopter landing? Yeah, that was amazing too. And hey, 1 second. Why am I? This is weird. Okay. Anyways, we'll start. Hope you guys are there. I have to admit people. Okay. Yeah. So vectors. What do you guys know? Like last year, I taught vectors to some of you. How many of you have I taught vectors before this? Any of you here?
For
How
2
many of
years.
you have I taught vectors?
For 2 years.
No one? Electricity
Yes.
workbook part is left. We will be covering that soon. Okay. The workbook part is left. We'll be covering electricity soon. Okay.
Can you hear us?
Siri, did I teach you a batch? Use Swasti and all? Vectors?
You should.
I think I. Hey, are you guys speaking? I'm
Yes, sir. We're
not
speaking,
able
sir.
to hear. Okay, 1 second. There's a microphone issue. Okay, speak now. Can you even say something?
Yes.
Yes. Okay, that was too loud. Okay. So Siri, what did you say? You were saying something. Did I teach? Yeah,
You
right.
taught us for 2 years.
Yes.
Okay. That's too loud. But anyways, one
It's
second.
echoing.
It's
Yeah.
echoing. It's too loud, like crazy loud. 1 second. Now, can you speak? Amit, mic test. Say something. Say something stupid. Hello.
Physics is fun.
Earth is flat.
Earth is flat. Okay, I can hear. Okay. That's good. We can go ahead now. Awesome. On that amazing notes from Wikipedia by our Siddharth, we will go ahead with vectors. So what I'll do is it will be a quick recap of your 9th standard stuff, whatever you studied, the beginning parts. Then we'll go into the 10th standard vector stuff. So this time we'll be studying some important ideas such as component resolution and so on. Okay. Some of you might already know about this, but we'll try our best to make sure there's something new even for you. Okay, so what is the, you guys remember, just going to do a quick recap. I want you guys to go on answering. I think we've done this before. Have we done this before? Just reminding again. Have we done this before? This part of the presentation somewhere. What is the vector representation of the vector? Yeah, quickly, can you do a quick exercise? Let's go on quickly with this. What are the components?
5 2.
5,2.
This is 5,2. What is this?
2,
Quickly say it.
5.
2,5.
2,5. You guys are good at this. Okay, you guys 2,4 in this case.
2,4. Sorry.
Yeah. What is this?
3 2.
3,2. Okay, so you guys, okay, some of you were in the last year. Okay. But do you understand this part? Do you understand this 3,2 part? What the vector representation is? So how we represent a vector is So it starts from the tail towards the head. Okay. And it's like we say it has 3 units in the x direction and 2 units in the y direction. That's how we represent it. This is a represent 3,2. Is this fine, guys? Does anybody else have a doubt? Like, I want to know how much you guys know because I'm trying to do a recap, right? So I'll go in more detail depending on whether you tell me if you do not understand something. Okay. So is this part clear? Can I get yes or no from everybody so that I can move on, or should I?
Yes, sir.
Sir,
Yes or no in the chat.
sir, if there is an arrow on the line, then how can you give it values?
Okay, so that's the question now. So the thing is, what are, okay, I'll just do a quick recap. What are vectors, first of all? What are vectors? Can anyone tell me what vectors are?
Something which has a direction and magnitude.
Anything that has
A direction and magnitude.
direction and magnitude. So the thing is, to represent direction and magnitude, how would you represent a so the idea is vectors are basically represented by an arrow, because arrow has a length, a magnitude. Agree with me? It has a length, right? How long something is, as well as there is a direction associated with that. Okay, I would have done a introduction to scalars and vectors, but I want you to remember this in the following way. We say scalars are quantities with a single number, like 25. I don't know. Give me some examples of scalars, guys.
Mass.
Mass is a scalar. Mass is a scalar.
Instance.
Mass is a number, right? Do you say my weight is 25 kg in the northeast direction? No, right? Your weight does not change depending on the direction. Weight varies. Sorry. Your mass does not vary in different directions, right? Your mass is the same. Okay.
Yeah.
Similarly, can you give me other examples of scalars? Come on.
Temperature.
Temperature is a scalar. Your temperature is 25 degrees centigrade at a particular point. Agree with me? It's not like in this direction, it's going to be somewhere that direction. Got this part? So it's a scalar. Similarly, anything that involves a number is a scalar. For example, the number of kids Prajwal will have in the future is a scalar. The number could be 0, but it's a scalar. Is that fine? Okay. Time is a scalar.
Yes,
so
sir.
anything that involves a number is a scalar. Is that fine? Arjun.
Yes, sir. Yes, sir.
Yeah, you were saying, I thought you were saying something. Okay. So that's one thing. That's a scalar. So a vector is something that involves not just a number, but also a direction. So it will usually be represented by not one number, but many numbers, like 2 and 3, like here. This is a scalar. This is a vector quantity. Is this fine? Now, in vectors, there's dimensionality. So depending on the number of numbers that are there, like for example, 3, 2, 1, this is a 3-dimensional vector, a 3-dimensional arrow. Okay. If I have two numbers, then it's a 2-dimensional arrow. Is that fine? Guys, this is a refresher for those of you who have not studied vectors before this. Because if you don't understand this, you won't understand anything else being taught in physics. I'm not kidding. That's why. Is this fine? Can I get a yes or no once in the chat? Once. Just tell me. I will go accordingly. I'm adjusting the pace based on that. Okay, cool. So next part. Can you guys represent this? I want an answer from everybody on. So far, for now, just don't try to understand things. Just be more mathematical. For now. Okay. Can you guys answer me this? I'm looking for answers from those people who told me that particularly that they didn't understand. They've not studied vectors before this. You don't want to represent properly, just tell me what the numbers involved are. There are 2 numbers involved. This is 3 units and 2 units. Is this fine? Okay, next one. What about this? This is a little bit tricky. Some of you know this, but 1 or 2 of you might not know this. 3 minus 2. Fine with that? 3 minus 2. Now, the reason minus 2 is because it goes downward in the negative y direction. Is this fine? 3 in the positive x and yeah, okay. This is easy. You can call it what you want by the vectors. Okay, these are just quantities. Is this fine? Okay, we've discussed this before. What is this? Quickly. I think we'll be able to do this quickly. It's a recap for those of you who have not studied this before.
2 minus 3.
2 minus 3. This is fine. 2 minus 3. You can call it what you want. Last time we did it. Okay. You can call it Dumbo, like Siddharth is calling, giving some weird names in the chat. Okay, what about this? What is this? What is this? I know you're counting on the screen. 1G, Raddu, Muji, and so on. Wait. Okay, 8 comma minus 3. 8 comma minus 3. Awesome. You can call it Rajul, whatever you want. This one, this is my favorite. What about this? This is a little bit tricky one. What about this? Yeah. It's
0,
gonna
3.
yeah, 0 in
3.
the x, 3 in the
-3.
in the minus 3 in the
Minus
y.
3.
Fine.
Yes, sir.
Cool, right? Yeah. This is k is equal to 0 comma minus 3. What about this?
Sir, 4, 0.
Yeah, 40, right? This is 40. 40.
Yes.
Yeah, yeah. We had an issue. I'm sorry. This is 40. Don't say it out loud, guys. I understand, but send it in the chat for now. Is that fine? Yeah. Okay. 4, 0. What about this? What about this? What about this? Quickly. Let's go quickly over this. Siddharth is coming up with nice names. Or Trump OP in the chat. It seems awesome. Nice. 1, 1. Easy. Straightforward. Yeah. Rashmi adding you to the room. 1 second. We called it Ananya. She was a classmate long back. I mean, student long back. Okay. What about this? This is fun. This is a new one. Careful. -2 because x direction is -2, but y gets still +2. So do not mess that part up. Okay. We call it Thor or whatever. Last time we called it Thor. Next time, what about this? This is 9th standard stuff, but we're just going to do
-3, 2.
2, -3, 2. Okay, fine. This is fine. This is easy. Quickly. Let's do this quickly.
4, 1. -4, 1.
-4, 1. Is everybody fine? Is everybody getting comfortable? This one, last but one.
-4, -2. 4, 2.
Okay, both are -4 and -2 because it's in the negative y direction also. Okay, now this one. I don't want this one. I'll do it. -6 and -3. Awesome. I'm faster than you guys. Next, what about this?
1, 0.
1, 0.
This is my favorite vector. What is this called? It has a famous name, popular name. In physics, we apply it with a cute name. What is
I.
it? I.
Actually.
I cap or I cap usually represented with the letter I. Okay, it's 1, 0. Okay, it's called a unit vector. Can you guys tell me why it's called a unit vector? For those of you who have studied, why is it called a unit vector? 1G vector.
It represents one unit of the
Unit
grid.
vector.
Yeah, it represents one unit of the grid, right? Can you see that? Got it? It represents one unit of the grid. But more importantly, what Siri said is the exact description of it. The actual description of it is its length is 1. Agree with me?
Yes, sir.
0 to 1, its length is 1. So the point is unit vector could be this one also. What is this? Do you agree its length is 1?
Yes.
Yeah.
Yeah. So this is the unit vector. What is the representation of this?
J cap.
0, 1.
The cap.
It is
J cap
popularly
0,
called
1.
J cap. People love this. IJ. Okay. This is J. Do not forget this. Yeah. Quickly, I just want to give a shout out to everybody who has what to say, who's new to this. Are you guys getting this? Like, I'm talking to everybody. 1 second. Okay. Just let me know in the chat. Is this clear? Because I know there's a lot of you who had questions. That's right. Awesome. Okay. Okay. Awesome. So what about this? What about this?
-1, 0.
I'm sorry if this is dragging for some of you. Yeah. How much is it? -1, 0, or also called negative I. Why? Because it's opposite to I, right? It's the one opposite to I. So minus I. Okay, done. What about this? Quickly.
-J cap.
Minus J. I won't struggle a lot. It's minus J, which is 0, -1. Now, what about this? Quickly? This one I want to do. What about this?
2 and 3.
We'll do this slowly. Send it in the chat. What is this? I want to get an answer from everyone for this one. Come on, try. Yeah, 3, 3 minus 2. Okay, 3 and 2. What about this? Well, I'll call it Meda, whatever I called it. What about this? The new vector which I do. The same. What about this? The same. The point being, it's the same. Got it, right? It doesn't have to be placed anywhere on the grid. There's no rule. Okay. Like it can be anywhere you want. The unit is 3 here. This length is 2. Is this fine? It doesn't matter. Okay. Done. So since we're done with it, you can measure the length and see it's 3, 2. Next is magnitude. The magnitude of vectors is something that we studied in 8th standard. The magnitude is, what is it? How big the vector is. What is the length of the vector? Agree with me? Fine?
Yes, sir.
Yes. Awesome.
Yes.
Let's go ahead. How do you measure the length of a vector? What's the strategy?
Pythagoras theorem.
Pythagoras theorem. You know the Pythagoras theorem, right? Everyone here knows
Yes,
Pythagoras
sir.
theorem?
Yes, sir.
Yeah. So if this has a side of 2 and this has a side of 3, then what is the length of this? 3 square plus 2 square, the whole square root, right? Agree with me? Got this logic?
13.
Yes.
Yeah. So in this case, it's going to be how much? Tell me, what's the magnitude of this vector of length 2, 3? What's the length of that? Root?
13.
13.
Root 13. What about this one? What is the length of this?
13.
13.
14.
The magnitude of this vector is 13.
14.
And magnitude is represented with this symbol. Is this fine? 2 bars along the side representing magnitude. You guys know the magnitude symbol, right? Minus,
Yes,
what's
sir.
the magnitude of this in maths?
2.
You guys know this. In maths also, do not forget that. Those 2 bars represent magnitude usually. Okay. What about this one? What's the magnitude of this?
13.
13.
This is also 13 because when you do minus 5 square, it doesn't depend on the matter, right? It's plus 5 minus 5. It's just that it'll point in a different direction. The magnitude is same. So if you look at 5, 12 and minus 5, 12, they have the same length, but they point in different directions. Is this fine? Can I go ahead?
Yes, sir.
Awesome.
Yes, sir.
Arjun, is your question earlier which you asked satisfied? Like, did you get an answer to that or?
Yes, sir. Yes, sir.
Okay. So addition of vectors. You guys remember this? How to add vectors? What's the method? Quickly. How to add vectors?
The parallelogram method.
Triangle law.
This is the triangle method. The triangle method is if you want to add vector A and vector B, what do? You get the tail of one of them to the head of the other. Is that fine? Got the logic? And then complete the triangle. Is this fine?
Yes,
The
sir.
vector. Now this is the geometric way of doing it, and the geometric method is called the triangle law. Okay. Leaving that aside, if you want to do it systematically, this is A vector, right? Agree with me? 1, 3. This is B, 3, minus 1. Agree with me? Mathematically, if you're doing it, this is how the addition looks like. Can you see this clearly now? This is 4, 2. Does it work out? The triangle method and the algebraic method.
Yes.
This is how vector addition works. 1, 3 and 3, minus 1 gives you 2. Yeah, my favorite words, parallelogram law. Okay, I can't pronounce that. No. I don't think I want to discuss this. It's fine. This is not so important for now. I don't need it. Okay, what is the sum of these two? There's one more method. What is the sum of these two? Can anyone tell me? I'll tell you what the vectors are. This is 3, minus 3, and this is 3 and 2. What is it that you get? These two vectors, when you add them, what do you get? Can you guys do it in your head and tell me what is the answer? Siri, you're right. Others. Karthik, you're right. Trevor, you're right. Others are wrong. Some of you messed up a little bit. Calculation error. That's all. 3 of you did a calculation error. Pranav, 0, 1 is wrong. Pranav, Atish, 6 and minus 1 is wrong. Sorry. 0, minus 1 is wrong. Okay, what are we doing? We add the first you add the x components, right? What are the x components? Tell me. What does it give you? What do the x components give you? 0 when you add them. What about the y components when you add them? What do you get?
5.
You get 5. So you get 0, 5. Is that fine? This
Yes.
is 3, 3. This is 3, 2. When you add both of them, you get 0, 5. Is this fine?
Yes, sir.
Guys, fine. Now, you could have solved this using the which law? Triangle law. Can you see this? Fine. You could have solved this using triangle law, 0, 5. Or there is one more method. What you do is, this is triangle law. Is this fine? This is triangle law, which you did. Some of you subtract, it's fine. This is called the triangle law. But if you arrange it smartly like this, you can also form a parallel, I can't pronounce this, sorry, parallelogram law. Is that fine? It's a tongue twister for me. I'm sorry. So this is called a whatever you see on the screen log.
Parallelogram.
Parallelogram.
Okay, I need some assistance. Okay, this is called the
Parallelogram.
Parallelogram.
law because there's a delay. I'm sorry. Because if you were to complete the
Parallelogram.
okay, parallel, whatever that thing, you end up
You
with.
just got it right. Congrats.
I got it right. Yeah. So this whatever gram law towards the end, you can see that if you the diagonal forms the vector, the resultant vector. Is this fine? If you were to take the both the
Yes.
vectors form a weird shaped. Come on.
Parallelogram.
Thank you. Okay, weird shaped parallelogram. You end up with the diagonal being the sum of this thing. Is this fine? Is this fine? Actually, it's nothing. It's not that different from this thing. What is that? The law that we have. Okay. Quickly. This is a book. Last year there was an example. We had this.
Parallelogram.
Yeah. O, A, C, and B. Okay. So we have the diagonals. The question is the following. This OA is called. This is the vector OA, and this is the vector OB. Is this fine? This is the vector OB. Is this fine?
Yes, sir. Yes.
Okay. Sir is giving me some help. Parallelogram. Okay, awesome. We'll do that next time. Okay. Listen up now. The question is, what is BC in terms of A and B? What is BC then from this diagram? What is BC? Quickly tell me. It's very easy.
A.
A? No, that's BC. Oh, okay. It's A. Is that fine? It's just A. So you guys can do this, right? It's easy. What about CA? CA. Quickly.
B.
Not B, minus B. Careful. Okay, it's minus B because it's in the opposite direction to B. Is that fine? B was upward, right? OB. Fine. Just doing a recap quickly. OC. This is easy.
A plus B.
It's going to be A plus B by trial the law. Okay, done. A plus B. Next. How to know if it's opposite direction? So the idea is, we were told that OB is the arrow. Okay, it starts from, this is where the tail will be. Okay, at O. Okay, B is where the head is going to be. So this is going to be a B. That's how we know the directions. It always travels from O to B. Okay, so yeah. Next, OC is done. What about this AB? What about AB? Quickly. What is AB? Yes.
B
What
minus
about it?
A.
Huh? This is a little bit hard. A minus B or B minus A?
B
One
minus
of you, some of you sent it. Okay, this is gonna be B minus A, and I'll tell you why B minus A, because yeah, there are many ways to look at this, but this is one of the methods. What you do is, if this was B minus A, let's say this is B minus A. Okay, this is B minus A. If I add this and let's say A, what should I get? If
B.
I add B minus A and A, what should I get? B, right? Do I get B? Is that a triangle law here? Can you see this? Can you see the triangle law there? Guys, can you see the triangle law? So that's why this must be B minus A. Is this fine? That's why this is B minus A. Okay, that's one way of looking at it. Okay, done. Next. What about this? B. This is easy. Now that you know it, it's easy. Yeah, Siri, you're right. Siddharth, you're right. Others, everybody once. This is going to be important again. I just need a recap quickly. It's going to be A minus B. The reason why it's A minus B is because when you add these two, this and this, you should be getting A. Okay, so this must be A minus B. Now, there is an easy way to identify whether it's A minus B or B minus A. How is that? Can you even tell me the technique from this diagram quickly? How to identify whether it's A plus B or B minus A?
Where the tail is the first term, the term that's getting subtracted from, and where the head is where is the second term, which is subtracting the first.
Yeah, I get that. Can we apply triangle law by changing the perspective? Yeah. You can play around. Fine. By changing perspective, do you mean a transformation? That's what you need to explain me. What do you mean by changing perspective? I'm assuming you're talking about transformation. Yeah. So Siddharth is suggesting seeing the tail or the head. Did you see this?
Yes, sir.
Yeah.
Whoever has the head of the vector, okay, goes to the first term. The second term will be the one who gets the tail. Is this fine? That's
Yes.
one. That's the easy way of looking at it. Okay. This is one more method of representing the vector PR. Is this fine?
Yes, sir.
I will skip this section because I don't think you guys need this. Oh, vector subtraction I need. I have to do vector subtraction. I'm really sorry. Okay. I need it. Okay. So this is one more way of representing a vector. Is this fine? PR
Yes.
based on the tail term and the head term. Is this fine?
Yes, sir.
Now, I want you guys to listen to this portion carefully because in volume 2, this is going to be important. Is this fine? In volume 2, when you're doing entire mechanics, this is going to help out a lot. Is it fine? That's why I can't skip it.
Yes.
Okay. Listen to me carefully. Even if you've studied this last year, listen to me. So if you have PQ and R, let's say it's some vector PQ and R, and if somebody asks you what is PQ plus QR, what is PQ plus QR? This is brown vector is PQ plus QR, right? Agree with me?
Yes.
Newton and mechanics, Saurav. When you're going to be doing velocity subtraction and so on. Okay. What is the sum of these two? Can you guys tell me? What is the sum of PQ plus QR?
PR.
14.
PR.
Or PR. Is this fine? Okay. But notice something interesting that happened. Q disappeared. Okay. That's one way of looking at it. Okay. One way of remembering triangle law. Okay. In this form. But my favorite is subtraction. Subtraction is if somebody gives you two vectors, this is the first step. Okay. Get them together. If you want to do vector subtraction, let's say somebody gives you two vectors and asks you to subtract them geometrically. The method is the following. What you do is get them together. The second step is namakarana. Give it some names. Is this fine?
Yes.
You want to subtract two vectors, get them together. Give it some names. Okay. Not RCB and all. Now go on. We'll give something that I can deal with for now. And I can't redo the PPT for now. Okay. So this is going to be PQ. This is PR, right? Agree with me?
Yes, sir.
Yes.
Okay. Quickly tell me, doing the subtraction now. This is the important part. What is PQ minus QR?
QR.
What is PQ minus PR? Can anyone tell me in the chat? What is it? What is it?
QR.
QR or RQ? Again, RQ or QR?
QR.
QR.
Who gets the head? Who gets the tail? PQ gets the head or PQ? Who gets the tail? Whoever comes first gets the head, right? Whoever comes first gets the head, right? Remember this? Earlier, we discussed this. Hey, listen. Chill. Not a problem. If you remember here, I drew, remember this diagram? I asked you. Okay, Saurav, don't tell the answer. Sorry, okay, I'm just don't tell the answer for now. 1 second. So listen up. This is A and this is B. Agree with me? Two vectors. And if somebody asks you what is A minus B, the way to identify that is, since A is coming first there, that one gets the head of the vector. And the term that comes second will have the tail. Is this fine? You guys fine with this? Okay. Now going back to our presentation, when I do the subtraction, get them together, we have PQ and PR. The question is, what is PQ minus PR? The procedure is, it's going to be RQ. The reason why it's going to be RQ is that this one gets the head. Remember, the first term gets the head. Can you see that? Who gets the head? PQ should get the head, right? Agree with me? PQ should get the head. It's the first term. It's the first term in the subtraction. PQ should get the head. Okay. What should RQ get? The tail. Agree with me? RQ should get the tail, if you remember. So this is the answer. QR, RQ. Is this fine? Guys, once yes or no in the chat from everybody. If you've forgotten, this is a brush up for some of you. Even they've learned it last year. Does anyone? Let me know in the chat. I will address them now. It's going to be RQ. The interesting thing that you need to note is that something interesting, something disappeared. Yeah. Repeat this part. For now, what you need to understand is the first step is get both the vectors together, which they have asked you to subtract. Okay, get them together. The next step is gives them some name, P, Q, and R. The common thing is P here. Okay, do not forget that. Is it wrong if it is QR? Yes, it is wrong. It's not QR. QR will be in the opposite direction. This will be QR. Listen. This will be QR. Is this fine? This is QR. Guys, fine with this? That's going to be QR. Okay.
Yes.
Now, repeating that one thing for someone who asked, this is PQ and this is PR. The end result will be in such a way that whichever vector is first among the two vectors, green, those two green vectors are there, right? Whichever is first, that is PQ, will get the head of the result vector. Is that fine? Whatever final answer you're getting, that its head will be at Q, at the first vector, PQ. Okay. The tail will be at the other one. Would it matter if it is RQ or QR if it were a scalar? No, it wouldn't matter. It's just a line. If it's a scalar, it doesn't have direction. It's just a line. Okay. One way of looking at this is I don't know, there is some mnemonic which you can use, which can work here. The first vector goes to the end and the last vector comes to the first in this case. This will be confusing. This might be confusing. Forget it. It's fine. It's totally fine. Is that fine? This mnemonic might be confusing for some of you, but hope you get the basic idea. Yeah. Can you guys simplify this vector? Can you guys try to simplify this? This is a common problem we gave last year to you. Okay. Quick question. If this is PR, let's say, if this is PR, what is minus R? What is minus PR? Tell me. Minus of PR, negative of that. What is a negative of a vector which is negative of PR? Tell me. What's a negative of the vector PR? What's a negative of that?
It will be in opposite direction.
It's going to be RP, right? Agree with me?
Yeah.
It's going to be RP. Does that make sense? Negative of PR is nothing but RP. Agree with me? Fine with that? Yeah. So what we do is, instead of writing minus PR, we write it RP. Is this fine? Guys, is this fine? This step is fine? Yeah. So I don't know whether you see it here. PQ is this one. PQ is this one. PQ plus RP. These two vectors, when you add them, you get what? RQ. Is this fine? Not QR, not QR. We did this problem right in the previous slide. PQ minus PR. It's the same thing. I'm showing you one more method of doing the subtraction. I'm showing you how to use addition to do subtraction. Can you see this? Did you guys get every step? This step you understood, right? How I went to RP. Once I went to RP, I rearranged it so that P came in the between. Can you see that? I converted subtraction to addition. That's all. Okay. Now, this is also important. This is important in terms of this year's sense. This is sense transfer. Okay. But you guys have, some of you studied this last year only, like 9th standard stuff a little bit. This is I, right? Remember this I, Chotu vector I. Yeah, but the initial equation is the same as the previous question. Yeah, I was trying to solve this question. The final answer for this was RQ, right? I told you directly it's RQ. Okay, the answer was directly RQ, PQ minus PR. I am doing the same thing, PQ minus PR here again. What's the answer I'm getting? RQ. Same answer. The answer is the same. Okay, now this is our I vector, this is our J vector. Is this fine? Okay, so the important thing is any vector that you take, any vector out there can be represented in terms of these vectors. For example, before that, can you guys tell me how much is this vector? Others who have studied this before, can you guys tell me in terms of I and J, what is this vector? In terms of I and J, how many I's do you require? How many J's? How much?
2i plus j. 2i
2i
plus j.
Plus 1j.
2i plus 1j. Agree with me on this? This is very easy. This is actually 2,1. Agree with me?
Yes, sir.
If you were to take 2, I'll write it down, 2i plus 1j. If I were to write it down properly, 2 times how much? 1, 0
1,
plus
0.
1 times
0, 1.
0, 1. What does it give you totally? Oh, by the way, I'm not taught a scalar multiplication, but remember this. 2 times 1, 0 is how much? This is multiplication of
0.
multiply.
2
What do you
comma
get?
0.
2 comma
2,
0 plus how much?
1, sorry,
1
0,
times
1.
0 comma 1. How much is that?
0, 1.
0,
You
1.
get 2 comma 1. Is this fine? Which was obvious, right? You guys knew this.
Yes, sir.
Fine with this?
Yes, sir.
Let me know if it is fast, okay? I'm really sorry. It's going to be a little bit. This is actually a recap. I'm trying to do a recap here. That's right. But I'll go as slow as possible, depending on your questions. Okay? Okay. Now, the point is, what is this? We have done this last year. I gave it as a puzzle to you guys. What is this? Can you represent this in terms of A and J? How much of A's do you require? How many J's? This is a puzzle. This is a puzzle. Take this as a puzzle. How many A's do you require? How many J's do you require?
5a minus 3j.
No, don't say it out loud. Send it in the chat. How much is it? 5a minus 3j. Now, why 5a minus 3j? Because I can add 5 of those A's and then what?
Subtract 3 times j.
Subtract 3 minus J's. Is that fine?
Yes.
Getting it? Because this minus J will be this one, opposite direction, minus J. I want 3 of those. Is this fine? That's a puzzle. So if you're going to do it systematically, you're going to end up getting 5 comma 2. You can see that here, right? 5 comma 2. This vector is 5 comma 2. So you can represent one vector in terms of others. Is that fine? But for that, you need to already know what those vectors are. That's the important thing. Okay. Next part. This is everybody's favorite basis. Everybody loves this. So these vectors, which you use to represent other vectors, are called bases. Is that fine? The word is called basis. Basis vectors. Fine. I am sorry, today's class is very mathematical because it is mathematics, vectors. Is this fine? These are called basis vectors. I, J, and so on. Okay. Everybody loves these vectors. These are unit vectors. Yes, these are called unit vectors, and they love them. Okay. This is everybody's favorite basis, I and J. There's also K for the Z direction. Okay. Yeah. Can you guys tell me what's the representation of this? If you remember from last year.
Okay.
This is a challenge. Send it in the chat. Send it in the chat. Send it in the chat. This is a challenge. If you remember from last year, I've given you A, I've given you J. You have to give me what is capital letter A. How much of each vector do you require? Can anyone crack this? Do not say it out loud. Send it in the chat. I'm pretty sure. Come on, some of you must be able to solve this. You've done it before. Okay, one suggestion that came is 3 and minus 3. One other suggestion was A. Okay, we'll take one of them. One suggestion was A minus 3j. Does it work? Let's try. How many A's? Okay, we'll go. This would be A, right? 1A, done. A is done. We walked A. Okay. Next step is how much? Minus 3j. Minus 3j. Okay, this is J. This is minus J. Agree with me? This is minus J. So I need to go like this. 1, 2, 3. Okay, does that look like A? No, that's something that's not going right. Yeah, that doesn't work. What about others? Can anyone suggest anything? How many A's, how many J's? You have to specify exactly how many A's, how many J's. So far, no one has given a right answer. Despite doing this last year once. Okay, let's see whether you guys can crack this. This is fun. It's like a puzzle, like how many A's do you require, how many J's to reach this thing. Two A's and 4 J's. Okay, let's just try. 2 A's will go out of my screen. Okay, 2 A's will go out of my screen. Then if you do J's, it will go crazy out of my screen. Oh, 2 J's, you're saying 2 J's. So here, and then here, like this, you're saying. Somewhere here you'll be able to reach. But that is not A. That is not A. A minus 2j is wrong. So far, none of you given right answers. You want to know the answer? Can I get yes or no? Do you want the answer? I'll give the answer.
No, sir. Ask at the end of the class. So that can enough time. Got it.
Wait for a second. Okay. A plus 2j. Let's try a plus 2j till then. Does a plus 2j work? Let's see. A, this is a. 2j comes very close. Very, very close. Can you see that? A plus 2j is very close. So this is your hint. It's the correct answer. Almost the correct answer. A plus 2j, whoever gave, is very close. I think Swasti gave it. That is very close. It comes really, really close. 5 minus j plus j is 5a. 5 minus j, sorry, 5a minus j plus j will be 0. Just 5a. Okay, one person gave the answer. Only one person. I got the answer. One person got the right answer. Yeah, two people got the right answer so far. Yes, Stuti got the right answer. Yeah, okay. Trevor got the right answer, and who else? Wait. Karthik got the right answer. Yeah, what's the idea, guys? What's the idea? You require
Just
half
take
of it.
some.
You require half
Yeah.
of it. You require half of it, and then you don't require the full A. You take half of it, and then you take 1 of J. Is this fine? So the point is those numbers can be even fractions. They're not just limited to integers. Yeah, Priyanka, you were very close. Yeah. Now, is this fine? Is this fine, guys? Quickly. Yeah. Awesome. So this is representing one vector in terms of the others. In general, what's the method? What's the strategy? How to find these answers? In general, how to do it? You assume that the numbers are n1 and n2. In general, you assume that the numbers are n1 and n2 because we have a and j, right? Fine. Okay. But what is a and j? Can you tell me? A is 1, 1. J is 0, minus 1. Agree with me?
Then we multiply with the vector.
Yeah. The next step is multiplication. Now, can you guys tell me what happens when you multiply n1 to 1, 1? What do you get?
n1, n1.
Others, can you tell me what is that? Oh, no, it's fine. I'll do it. It's fine. It's fine. It's going to give you n1, n1. So you must understand something about vector multiplication. When you multiply, let's say 4 times 1, 2, and 3. Can you guys tell me what this is? What is the multiplication? If you multiply a scalar, a number,
4, 2, 12.
you'll get a vector
4, 8, 12.
4, 8, 12. Is this fine? It gets scaled in all directions when you multiply vector. Okay. This is just scalar multiplication for this. Okay, we've not studied it. Okay. So when you multiply n2 into this thing, you get 0, n2. Is that fine? Okay. Now the question is addition of vectors, the final step. When you add both the vectors, you get n1 at the top. In the bottom, you get n1 plus n2. Is this fine? So now it tells you that this equation directly tells you, comparing the vector. If I were to show you a vector 3, 4 is equal to, let's say, 1 plus 2 and 4. Do you agree they must be equal? They must be equal, right? Component wise. Look, good question. What is this? If this was A, what is the value of A? What is the value? A should be 3, right? Agree with me. A should be 3. Something is wrong otherwise. So what is n1 there? What is n1? What does it tell you? What is n1?
5.
N1 is 5. So it immediately tells you that n1 is 5. And then it tells you additional information that when you add n1 plus n2, you should get 2. When can that happen? If n1 is
1.
n1 is, sorry, n2 is, sorry, n1 is 5. So n2 should be how much?
1.
1? No, 3, right?
Minus 3.
Sorry, minus 3, right? Fine with this guy?
It would be my.
Yeah? Okay. So it will work, okay? What we just studied. So what this? Did you see this earlier? That this works? Oh, we saw this. 5a minus 3j. Yeah. Okay, now comes the other important set of the problem. We have done this before, remember? Does anybody remember doing this? Crossing the rivers.
No.
What?
Oh, wait, the vector questions.
Now keep quiet.
Yes, sir. Yes, sir. We did crossing the river once.
Keep quiet. What I'm about to do is important. I'm going to test how many of you remember this now. If you forget this, and this goes to all of you who have taught before, including Amit and all the gang, to the end of Swasti, to Siri and everybody. If you get this wrong, yeah, Saura, you remember this, yeah. If you get this wrong, listen, I'll do this. I'll ask them the question and let's see if they get it wrong. The question is the following. I have a river, nicely flowing river. The river is flowing east. Online slap, no. I will come to your house, find you. Okay. Anyways, so listen up. So there's a river which is flowing. What's the direction called? East, west, east. Sorry, east. Yeah, it's flowing
East,
east.
sir.
It's
Flowing
east.
Yeah, right. East. Now, so we have somebody wants to cross the river from across A and B. Okay, but there is a problem. He has a boat which can travel at a maximum speed of 4 km per hour on a normal road. Is that fine?
Yes.
In normal water, here, okay, normal road in the sense normal water. Its top speed is 4. Okay. Now the problem is when you put a boat in the river, even though it's traveling at 4 km per hour, the river will push it additional 3 km per hour. Does it 3 km per hour? Does that make sense?
Yes.
Yeah. So my question is the following. What is the resultant velocity of the boat? Do not answer loudly. Send it in the chat. Do not give the wrong answer. What is the resultant velocity of the boat? Amit, are you doing this on purpose?
What?
Swasti, are you doing this on purpose? We have discussed this last year. Siri, thank you. Trevor, thank you. Niam, thank you. That's right. Okay, that's right. Guys, I'm coming to your house in some time. What is the resultant velocity of the boat when you put it in the river? It's not 5, guys. It's not 5. It's not 5. Listen up. The resultant velocity is P plus Q. Agree with me? The sum of the two vectors. Velocity of the boat plus the velocity of the... Agree with me? It's the velocity of the boat plus the velocity of the river. Does that make sense? Yes. So that's going to give you... What is the... Okay, quick question. What is the velocity of the boat? Can you guys answer in the chat? What's the velocity of the boat?
4.
Huh? Yeah, tell me. Amit, you're right.
4.
0.4.
0. Yeah.
Siri, you're right. 0.4. Is that fine?
Yeah.
What is the velocity of the river? What is the velocity of the river?
3.
30.
30. Now, important thing you got to understand, what is the speed of the boat? Top speed of the boat.
4.
What's the top speed of that is 4. Okay. So the important thing I want you guys to remember is that speed. What is speed? Can you guys tell me? Can anyone define what is speed? What is speed?
Distance travel per time unit.
Forget that for now. Okay. It's not speed by time. Go with what? Distance by time. Speed is magnitude of velocity. Speed is magnitude of velocity. Is that fine? Whatever the velocity of the vehicle is, when you take the magnitude of it, what value you get, that's the speed of the vehicle. Is this fine? Understood the difference between speed and velocity? Speed is a number. Velocity is a vector.
Vector.
Velocity has direction and it has value. So for example, here,
Speed
the
is
velocity
scalar.
of... Yeah.
Speed is scalar.
Speed is a scalar, velocity is a vector. Is this fine, guys?
Yes.
I am trying to make sense of what's happening. One second. Yeah. So listen up. So here, velocity of the... Holding the pen ulta. So the velocity of the boat is how much? Velocity of the boat is 0.4. Whereas
0.4.
speed is the magnitude of that
4.
velocity, which is 0.4. Remember Pythagoras theorem, the magnitude? Fine. For the first,
Yes.
those of you are studying this for the first time, can you give me a yes or no, please? Okay. So what happens is, Okay. Okay, this is a little bit tricky part. So you guys know the difference between speed and velocity? One of you answer me. Do you know that part? Did you get that part? The difference between speed and velocity? Okay. So if okay, everybody answer this. Everybody answer this. If I give you the velocity to be, let's say, 5,12, the car is moving 5 km per second. Okay, meter per second. So it's moving 5 meter per second in the x direction, but 12 meter per second in the y direction, which means it's moving more towards the y direction. The car is moving more towards that direction. Yeah, famous part of this lesson, kidnapping in Omni. I remember, but we'll not do kidnaps this time. But for now, is this fine? 512. Awesome. Okay. Now, what is the speed here? Can you tell me what's the speed of the car now? At this instance, what's the speed of the car? The speed of the car is 13 meter per second. The reason is that's the magnitude of it. If you were to do take the magnitude of this vector, that is square root of 5 square plus 12 square, you get 13. Is this fine, guys? Okay.
Yes.
Okay. Can I get a name quickly? A name?
What?
You're not. I wanted a name. That's all. Okay. Let's say we
Amit.
have an electron. We have an electron by the name of Amit. Is that fine? Okay, which is flying through space in some random direction. Now, this Amit of us, which is flying through space or whatever, has a velocity of 1, 1, and wait. Let's adjust it. No. Okay, 1, 2, 2. Can you guys tell me what's the speed? The velocity is 1, 1, 2, 2. Can you tell me what's the speed? Speed of this electron as it moves through the air. What's the speed? Square root of, what's the magnitude of this? What's the magnitude of this? Square root of 1 square plus 2 square plus 2 square. Is that fine? For a 3-dimensional vector, that's how we do it. If there are more terms, you go on squaring them. What do you get? Can you guys answer? For those of you particularly who told me didn't understand. Like I'm trying to tell you guys exactly what's going on. For others, it's just a challenge. Square root of 1 square is 1. 2 square is 4, right? Yeah. Again, 2 square is 4. How much is that? Square root of?
9.
9. Square root of 9 is how much?
3.
Is this fine? Is this fine now? Clear? Can I proceed? After identity, 1 second. Yeah. So did you guys get that part, right? So speed is usually, okay, in a car. Why is speed a scalar? You know the speedometer in your car? I've mentioned this before. You know the speedometer in your car? Does that go to negative?
Yes.
It's just a number, right? The speedometer is negative. Even if you take a reverse, the needle will go always to the positive. Agree with some number. Okay. Speed is basically a number at the end of the day. Okay. Speed is just a number. Whereas velocity is a vector. It has some direction to it. Okay. Okay. And it's represented by more than one number. If I ask you what's the velocity of a car, you cannot say 5 km/h. If you say that, again, you know what's going to happen. Okay.
5 km/h in northeast direction.
Yeah, when you specify velocity of a car, you say the velocity of the car is 512. Okay, it will not be a single number. Is that fine? If the car is moving perfectly east, let's say perfectly, it's moving in one direction, let's say like this, then it's going to be something like 3,0. Is this fine?
Yes.
Yeah. What is a okay? Quick last one question. Let's say I have a velocity which is given to be 3,0. Can you guys tell me what's magnitude? What's the speed then? If the velocity is 3,0, what's the speed?
3.
3 km/h.
3. Is this fine? Square root of 3 square and 0 square. Is this fine? Okay. In other words, speed is the magnitude of velocity, or in other perspectives, speed is the length of the velocity vector. Is this fine? Because magnitude is the length of a vector, right? Got this part?
Yes, sir.
Vector is the length of the vector, right? So the speed of the vector is basically the length of it. Okay. Can I get a yes or no from everybody? So that's the explanation on what is speed, what is velocity, so that you know this in the future clearly. Do not mess this up ever. Okay. Yeah. Now, next part. The important thing you got to understand is here in this case, what is the velocity of the boat? 0.4. 0.4. That was done. But what is the speed of it? What's the speed? Just 4.
4.
It's the magnitude. Awesome. What is the next question? What is the velocity of the river here? What's the velocity of the river? Send it in the chat. What's the velocity of the river? 30. Is this fine? This is 30. If you look at Q, that's the velocity of the river, right? 30. What is the speed of the river? 3. Now, important thing you got to understand is in all physics problems that will be taught to you, you won't be given velocity. You will be given speed. Is that fine? Usually, let's say Amit is telling me about some car accident. He'll be like, you won't be telling the car was going 3 kilometers, 3 kilometers north, 4 kilometers west, right? Do you agree? He'll be telling the velocity like that? No, if Amit is describing me a car accident, he'll be like the car was going at 4 kilometers per hour. Agree with me? He'll never be saying anything about the velocity. Usually the information in problems, physics problems, is speed. Speed will be given to you. Okay?
Yeah,
You will
but
never be given.
sometimes
Yeah.
tell it is velocity.
Yeah. What?
Like they gave it the
Sometimes-
velocity of the car is 24 kilometers per hour.
Yeah, sometimes they give. What they'll tell you is the speed of the river. Here, the river is flowing. Listen to the words. The river is flowing. Oh my God, I shouldn't have written this. Okay, river is flowing. Hope you understand the handwriting. River is flowing 3 kilometers per hour east. What does that mean? This term, this thing, whole thing together means velocity or speed. Is that velocity or speed?
Velocity.
That's velocity. So that's the moment you know the vector is, it's a vector 3, 0. The information has to be extracted from the problem. Is this fine? Awesome. Okay, so that's what we did here. So what we figured out was the speed of the river was so much, speed of this thing was so much. So what is the resultant speed? Okay, what is the resulting velocity of the boat? Quickly tell me. What is the resulting velocity of the boat?
3, 4.
Yeah, when you add both of them, you get 3, 4. Okay, what is the resulting speed of the boat? If you check the speedometer on the boat, what will it show? Oh no, that will be wrong. That will be wrong. Don't
It
go
will be
with that.
4.
It actually won't be. How much is it? If you check the speedometer.
4.
The speed of the boat is 5. Okay, speed of the boat is 5. 3 square plus 4 square. The magnitude of 3, 4. Is this fine? So usually it's understood. So there's a question of if the problem say north, east, west, or how do you take the direction? Usually this is understood. This is the common directions. The map directions are there, right? We go with that. Yeah. 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 Okay. Yeah. Sure. Yeah. Cool. So in the speedometer, it won't be 4. In the speedometer, it will be 3. I'll discuss that. Sorry, 4. Sorry. Yeah. I'll discuss that later. Okay. So this is going to be 5 kilometers per hour, this speed. Okay. Now, this time, can you guys solve the problem for me? This time, 8 kilometers per hour now. 3 kilometers per hour, 6 kilometers per hour is the speed. What is the resultant velocity of the? What is the resultant velocity? Again, the same problem. What is the resultant velocity of the boat? You guys can answer this. It's very easy. Now, it's going to be. These are the velocities and the speeds of the boat which are given. What is the resultant thing? 6,8. Okay. The speed is 10. Speed is 10. Yeah. Or you can specify it like Niyam says, which is not almost right. Okay, answer me this. This is very close. One of the answers I got in the chat is the speed, there's the velocity of the boat is 10 meters per second northeast. Is that correct?
No, because it's not 45 degrees exact.
Yes. This angle is not exactly 45 degrees. Got the logic? That's why it won't be. 10 kilometers per hour. 10 kilometers per hour. Yeah. Per hour. Sorry. Got this part? It won't be exactly northeast. So you cannot specify northeast like that for these problems. It'll be a little bit tricky. Fine with that, guys? Why not northeast? Yeah. I'm sorry if it's fast. Okay. Again. Okay. What about this time? This time they tell you that the boat he is put in the river with the speed of 8,5. It's been put in the river with the speed 8,5, and the river is flowing at 4 kilometers per hour. What is the resultant velocity? What is the resultant velocity? 8,5 is the velocity of the boat. and 4 is the velocity of the river. 40 is 12,5. What is the speed of the boat? What is the speed of the boat? Speed of the boat is 13. Is this fine? Did you guys get the whole idea of speed and velocity? This is like, it's the most important thing here. Take away. Can I get a yes or no from everybody? I think most of you know it. Like from previous years, you guys know it. And by the way, if you use the parallelogram law, which I try to pronounce really well, thanks to Siddharth, you will see it works. Okay, it will work. This will be the resultant velocity, which will be really lengthy, like 12,5. 12 in the x direction, 5 in the y direction. Okay, done, awesome. Let's go ahead. There are some online simulators. You can see this. Now, I'm going to give you a very important idea. So listen to this part carefully. Something that I've not mentioned before, okay, to even your batch. So here's an idea. So there are some simulations which can help you understand what's going on. So here's a boat which is trying to reach the other end of the river. I think this is the velocity of the boat related to the river. Okay. This is related to the earth. Okay. So you can change directions, but I'll just see this. Depending on the speed of the river, you can go faster and faster, right? One second, I will reset this. Yeah, here, I'll give a large speed to the river. Okay. Can you see this? Can you guys see this? Like, okay. This simulation actually gives you makes my point really clear. But there is something I want to add. Okay, there's something I really want to add. Think of the river as an escalator. Have you seen an escalator? Hey, you guys have seen those escalators, right? In the airports and all.
Yes, sir.
Yes, sir.
Yeah, 1 second. I'll have to do something. 1 second, 1 second, 1 second. Motion. Give me one moment. I'll open a different PPT to show you something. 2020. I'm hoping this is the one. Wait. Let's share the PPT 1 second. Can you see the presentation?
Yes, sir.
Yes.
Okay. 1 second. We will discuss these parts later sometime. 1 second. Somewhere there. Okay, there's a lot. I should have.
Which class is this?
There's a lot. 1 second. There's a lot. I should have opened somewhere else. But it's okay. It's closed. Not this. Yes. Got it. So, this part. River part. Yes. Think of the river like an escalator. Can you see this? Have you seen these escalators? So what's happening is you're taking a race car or a boat and putting it on an escalator, which is already, it's a moving platform. River is a moving platform. Got it, right? The river is moving constantly and you're putting your vehicle on top of it. Got this part? That's the idea I wanted to show you. So basically what's happening is the river flows at a steady rate, flows nicely. And you put your boat, which is moving at a certain speed, on top of it. So when you put it, okay, this is a relative motion, but I won't come to this, but you get the idea. Right? Okay. Yeah. This is a 10-stamp PPT itself. We'll discuss that part later. I'll show it to you later, the bits of it, which I need for this thing. Yeah. There are other simulators. This is one more simulation which I've seen, which also communicates really well the idea. Can you see this?
Yes, sir.
Yeah. So yes, Saurav. Yes. So we have a particular board speed that has been there, which you need to, I think, show velocity will help. I think I want to. Yeah, I can do this. Yeah. So if you can see this, there is a board direction which you can set and show velocity. Show velocity. Yeah. Reset. So speed of the river, you can adjust here, speed of the river. And I have the river width, which is irrelevant. The speed of the boat is going to be important, as well as the direction. Now, let's say I want to go to the other end of the bank. Okay, I want to go to the other end of the bank. I'm playing simulation. Did I go to the other side? Exactly. Did I go exactly to the other side? No, right? I did not go exactly to the other side. I went slightly towards the downwards. I went a little bit downstream. Now the question is, let's say this is the top speed of my boat, 11. I'm not going to change that. Let's say I can't change the speed of my boat. Okay, this is the problem. I can't change the speed of my boat, but I can change the direction. Is it possible for me to just change the direction? Oh my God,
Yeah.
can I? Is it possible for me to just change the direction? I'll share the link. How to change the direction?
So you're supposed to reset it every time.
Only reset. Oh yeah. Sorry. I'll reset. Thank you. I will reset it. Do you think if I change the direction this way will work?
No,
No. How much should I change the
it will
direction?
make it worse.
How many degrees? How many degrees? Make a prediction. How many degrees? How many degrees? Which direction? Southeast or whatever. 45. You're saying okay. Let's reset and try 45.
Sir, can you keep the speed of the boat a bit?
No.
Like,
Speed is 11 only.
keep
Speed is
calculate.
11. You can't adjust the speed. Okay, 45 we'll try. Some one of you suggests 45. Let's see. No, too much. At that speed, it's going that way.
Sir, 30 degrees.
30. You want to try 30? Okay, 1 second. Reset. Thank you. 30. Okay, let's try this. How much?
10. 20 degrees.
Okay, we'll try 20. Let's see. Yes, 20 worked. 20 is almost close, but 20 is not the exact answer. Okay, 20 is not the exact answer, but it's close. So what I'll just show you something. I'll make the speed to be around the boat speed. I'll make it to be around 5. Okay, and where was it? What was I getting at? Give me one moment, guys, to think. Give me one moment. I have to think. Okay, got it. I'll make this 8. Okay, I'll make this 8. Can you guys tell me? Yeah, Nischit solved it. But this time, can you guys tell me how much velocity should I keep such that the speed is 8, river speed is 4? Can you guys make a prediction? What angle should I place so that I go next exactly will be able to cross the river straight? What is the direction I need to aim the boat at? Speed is 8. Can you tell me exactly how many degrees? Shushit, you're right. Kriti, you're right. Yeah. Okay. Let's try. I don't know. Let's try. So there are suggestions that have come up. One of the main suggestions, we'll try some of the other suggestions that have come up. We'll try 20. We'll try 45. We'll try 45 first. Okay, 45 is one of the suggestions that has come up. Okay, we'll try. Will it go? No, it won't work. It won't work. It'll be too much. You'll overshoot. What about next suggestion that has come is 20 also. Let's try 20 also. Some of you suggested 20. Let's try that. What will happen? 20 works? No. We're using trigonometry. Yes, you're using trigonometry. So that didn't work. What about some of you suggested 30 and some of you did it intuitive, some of you did it using math. If you try 30, perfect. Okay. Exactly 30. Yeah, exactly 30. It's exactly 30 degrees. The reason why it's exactly 30 is there's a connection. Now, before the sign task, how many of you here know trigonometry? Does everybody know trigonometry? Sine theta, cos theta, and can understand the logic behind it? Everybody. Okay, good. Then we can discuss it later. So there's a connection here. What's the connection here? 8 and 4. What is the connection? Sine 30 is how much? Sine 30 is how much?
1 by 2.
1 by 2.
Sine 30 is how much?
Which equals
Sine 30 was
1 by 2.
okay. Here's a very easy way to answer this. Here's a question. How much is the speed of the river? 4 downward, right? 4 downward, right? Okay. Now, if the boat somehow manages to produce 4 meter per second a vector in this direction, exactly canceling the 4. Can you see here? The x direction vector of the boat exactly matches the 4 here. Yeah. So if your boat can produce 4 meter per second upward, one of the components being 4, the y direction, you can achieve that. You can cancel the velocity. Does that make sense? You can cancel the speed in the x direction. Boat speed will be, yeah, it will cancel. So to cancel that, you require the value, and the value is 8 times cos 30 degrees, which gives you 4. Sorry, sine 30. Sine 30 gives you 8 times sine 30 gives you 4. So it kind of works out really well. Okay, I will discuss this in much detail later. Okay, much detail later. But for now, I think, yeah, give me one moment. I just want to see. There are other games and simulators based on this. Can you guys answer this before leaving? What is the result in velocity here? The boat is now going upstream. It's trying to go upstream. Okay, whereas the boat has a speed of a velocity of 8,5 meter per second. Can you guys tell me what's the resulting velocity? Careful, guys. The velocity of the boat this time is minus 4,0 because it's trying to go upstream. Sorry, velocity of the river. The river is flowing upstream. Sorry. The river is flowing west now this time. Yeah. So how much does it give you? Tell me. What is the sum? 4,5. Most of you answered 4,5. Is this fine? 4,5. What is the resulting speed then? 6.4. You get about 6.4 and take the square root. Okay. So in this case, you can use parallelogram law and get the answer. Okay, roughly. Okay, you will see that it will be in this direction, roughly, the velocity. You will get a beautiful thing like this. Okay, one of you asked me to share the link of the simulator, I'll forget that. This is the simulation I just played around with. Okay, I'm sending it to everybody. Hey, chat with everyone has been disabled. 1 second. I can only chat with Amit for some reason. Okay, is that fine? Did you
That
guys get
happens always.
Yeah, I don't know why. Oh, his name is first. A. Okay, that's right. I think so. 1 second. Give me a moment. I just want to see what's in the chat. What's in this thing? Yeah. Oh, this is about plane speeds and I'll remember what's happening, right? When a plane flies, it's moving in the wind, right? Which is moving, the air column which is moving. Yeah. So that's the link. So you have similar ideas here. We just discussed this, but it's fine. It's fine. Okay. I want to do one important thing. We tried this last time also. What is the application of parallelogram law? The parallelogram law, whatever there was. It is more intuitive in terms of forces. Okay, vector addition in terms of forces. So here's a simple vector addition problem we did last time. Let's say we have Prajwal and all of you decide to punch me in the head. Okay, in different directions. So one person punches me straight. Imagine, okay, who's going to volunteer? Any names? I know Amit is in the list. Okay, somebody raise their hands there. Okay, let's say we have one straight smack on my face, straight. Siri is in the list. Let's say other one comes from behind. Look, I have not bowed. Just mentioning that, okay? Just saying that. Now, the question is, let's say somebody slams in the other direction with the elbow in this direction with the force of 5,2. Is this force a lot? 5,2? Quick question. How much newtons is this? How much newtons of force is this? 0,3. How much is the newtons? How much newtons of force is this? Quickly tell me. Units newtons. How much is the magnitude of this? How much is the magnitude? 3 newtons. That's it. When you take the magnitude, it's just 3 newtons. What's the weight of 3 newtons? Roughly 300 grams, right? If you take anything 300 grams and hold it, that's the weight of 300. It's like basically you guys are not punching me, you're just, I don't know, touching my face. I don't know. That's like very less force, guys. It's not a lot. So it's not much harmful. We don't promote violence. So
Not deadly.
Yeah.
Not deadly.
Yeah, not so deadly. But yeah, I have promoted kidnapping in the past. Now, going ahead. These are the forces. Is this fine? These are the forces. Ultimately, the question we are trying to answer with this is, which direction does Prajwal's head fly? Is this fine? We want to know which direction does Prajwal's head fly. Which direction does it fly? Can you guys tell me? What is the resultant force? The total resultant force of all of them. You have to add all of them, right? Yeah, what do you get when you add all of them?
I think minus 3,4.
Okay, you think it's gonna fly northeast? Sorry, southwest. Yeah, right. Do you think it's gonna fly southwest based on this diagram? Like, which direction do you vote for? Yeah, I will do the calculation. It's going to give you 3,4. Okay, it's going to be northwest roughly. Yeah, northwest. So the point is the head is going to relatively fly in the direction, but the magnitude of the force, total resulting force is 5. Of course, my head will be completely deformed because of all the punching and whatnot. Okay, but you get a net force of 5 newtons in this direction. So parallelogram law, which you saw earlier, makes more sense for forces. Okay, adding these two gives you this direction force, so force in this direction. When you add this vector A and B, this will be A plus B. Is that fine, guys? That's parallelogram law. Okay, parallelogram law, whatever. Done. We will discuss the rest of the things some other time. Okay, today was a little bit of a mess, but most of a recap. I'm sorry for the delay in the beginning. If you have any questions, I'll take them. Otherwise, we're done. Yeah, tell me. Electricity, I will continue. Okay, next time. I will continue from. Will there be any videos? The problem with this chapter is it's more mathematical. There will be videos, but they're yet to come. This was a recap. Actually, this is 9th standard, whatever I did so far. I'm not kidding. This whole thing is 9th standard. We did this in 9th standard. So it was a recap. The full session was a recap today. Except certain things were additional. Yeah. The KVL problem. Yeah, I gave a KVL problem, right? Yeah. Did you guys get the answer to that? The electricity chapter. Yeah. Oh, by the way, you guys can leave, okay? If you don't have any questions, you can leave. It's fine. Totally fine. I just want to address the KVL question. What is there? Wait. Is it? Yeah. That's actually an easy problem, the KVL one. Okay. I will teach her about the equations part. Do the plane and the boat problem have the same logic? Yes. When the aeroplane flies, the wind carries the plane towards the side. Okay. I will just discuss the electricity part. 1 second, so I can take more questions. Wait. Electricity. So this is no. I should have started the PowerPoint presentation. It's gonna be too far. Give me 1 moment, okay? This is gonna take some time for me to scroll down to the actual slide. Is it better to teach online or offline for teachers? I prefer offline. Online is fun, it's the same thing, but okay, I prefer online for the chat. Chat is fun, okay? But and your answers can come individually, so even those kids who will not be that responsive in class can respond here without the fear of whatnot. So usually people are more responsive online, but offline is fun because no, online is fun, right? You guys can cook, you can eat kebab there and listen to the class. And in online classes, you're not
You
kind
can
of
even
allowed.
sleep.
You can even sleep, yeah. And that's kind of, wait, that's not allowed, but I can't do anything about it. So, yeah. 1 second. I'm trying to read there. Presentation reaching there. Got it. We skipped some fun things actually in that electricity chapter. I'll do it some other time. Can you see the presentation? We skipped the 3 idiots, this thing.
I remember the scene.
Yeah, if you remember the scene, we actually did a calculation, but we skipped it. Anyways, 1 second. I'm trying to find that. Oh, KVL case here. So this problem, if you see here, this had 2 batteries, right? If you remember, and it was really annoying. Yeah. I gave this problem like a challenge problem for you guys to solve, if you remember. And I asked you what is the currents. Okay. The first step is what? Tell me. Namakarana, right? Current directions. Give them names. There are 3 currents. And the next step was Give them directions. Give them directions. So I set the direction that the current is going to the negative end of the battery, which is I think relatively true, a truthful thing. So this is current I2 and this is current I3. There are so many branches. The next step is apply KCL. Now, how many junctions are there? Quickly, junctions how many are there? 2 junctions, right? Okay, so I can apply KCL in 2 places. Now I'm going to apply KCL here. What do I get? Tell me quickly. Tell me. What do you get? I1 is equal to I2 plus I3. Is this fine? Okay, if you apply it here also, you'll get the same rule. So you don't have to struggle because here it will be I1 will be coming in and I2 will be into the branches. So you'll get the same equation there also. So that's done. One equation we got. Keep it aside. That's the first equation. That's KCL. Next is KVL. Now for this, you need to specify some direction, loop direction. Yes. So you specify loop direction. I'm going to specify anti-clockwise for both loops. Is this fine? Can I get a yes or no? Okay, awesome. Now, here's the important thing. Once you set the loop directions, the next thing you got to do is you start walking. You start walking in that direction. Now, before walking, you need to ask a few questions. You need to look for batteries. First, you need to look for batteries and then look for what is the equation? Voltage drops is equal to voltage gains. So basically, one way of looking at this, these are the places where gains happen. That is batteries. This is batteries. Okay, this is battery and this is resistors. Is this fine? Any direction you can take. My choice. I took I2 to be downward. Your call. You can take it to be the other way also. If you take it other way, if you take I2 to be in this direction, then this equation becomes complicated. This equation becomes I1 plus I2 is equal to I3. Then your equation becomes that. Equation changes because then if the current is flowing away from this node, if it's flowing away from this junction, then I2 and I1 are flowing away. Agree with me? So they come on one side of the equation, whereas I3 will be coming to the junction. So it will be on the other side, current coming in. So that's what happens. Okay, guys. Now going ahead, first thing you do is you figure out which are the batteries. Where are the batteries in this loop? First loop. Which one am I doing? Yeah, this one. Tell me here. I think, am I doing here? Yes, here. First loop, in the first loop. Tell me, how many batteries are there? Quickly, how many batteries are there? One battery, right? Now, I start walking in this direction, around this, in this loop. Okay, I start walking around. Now, as I walk around, do I go from the positive end of the plate to the negative end or negative to the positive? Say it out loudly, it's fine.
Positive to negative.
I go from my negative end of the plate to the positive end of the plate, right? Agree with me? Yeah. So since I do that, the value of the battery that you take in the loop is going to be positive 20. Is that fine? That's the condition when you walk around. Is there any other battery as I go around? No. If there was another battery here like this, let's say this was plus 20 again. Okay, minus and plus. Then as I go around the loop, again it's going to be plus 20 or minus 20 if there was one more battery here. If this
It'll add more because the two batteries are in series. So it'll be 40.
Yeah, you can do that. But if it was ulta like this, let's say positive and minus like this, then as you go in the direction in the loop,
You have to subtract.
yeah, in the loop direction, if you go like this, if this end was positive, then when you go around in the loop, you will be first going to the positive plate and then go to the negative plate, right? Agree with me? If there was an extra battery there, then you land up with another minus 20. Is that fine? If that happens. But in our case, that's not there. Okay. So batteries are done. Next step. How many resistors are there? 2.
2.
Okay. 2 resistors. Now, let's say we go through the loop. First, we go through this resistor. As we go through this resistor, quick question. Is the current flowing in the direction of the loop? Yes. The current I2 is flowing in the direction of the loop. And the resistance is 2 ohms. So what's the voltage drop across this resistor? 2 times V is equal to IR, right? So what's the voltage drop across it? I2 times
2.
The resistance R, 2. So 2 I2. That's what I have written here. And it's positive I2 because it's in the same direction as the loop. Is this fine? It's in the same direction.
I do not understand the 2i2. Can you just
Okay, 2i2 part is, so we want to figure out what is the voltage drop across this resistor. Okay. Now the voltage drop across any resistor is given by Ohm's law, right? Current flowing through it times the resistance. Yeah?
Yes, V is yes, sir.
That part is true. Okay, okay. So what is the resistance here? 2. What is the current? I2. We know it's going to be 2 times I2. That's the voltage drop here written here. Okay, that's the voltage.
So V is equal to IR, sir.
Yeah, V is
sir.
equal to IR, right?
Okay, sir. Got it.
Yeah. So V is equal to IR. But again, there is a condition. Is this going to be plus 2I2 or minus 2I2? It's going to be plus if it's going to be in the same direction. If the current is in the same direction, we take it plus. Is that fine? As the loop. Okay. Now, as you scroll down and you go here, you come across this resistor. This is a loop direction, right? Okay. Is the current, what is the voltage drop here? Quickly tell me, what's the voltage drop? 4 times
I1.
I1. Is it going to be positive or negative? That's the important part. Positive or negative?
Positive.
Positive
direction.
because it's in the same direction as the loop. Is this fine? So I've written plus 4I1. Is this fine? Awesome.
Yes, sir.
Okay. Next part, if you do it for the next equation, if you go around in this loop, how many batteries are there now in this loop? How many batteries? One. That's the only battery. Now, again, in this battery, as you go in the loop direction, do you go from the negative end of the plate to the positive or positive to negative?
Negative to positive.
You go from negative to positive, right? You gain voltage, right? Agree with me?
Yes.
As you go in the direction of the loop, you go from a negative end of the plate to the positive end of the plate. So you end up with plus 20. Is this fine? Clear?
Yes.
Okay. Next part, quickly, we'll do the drops. So as I go around, there is this resistor. Across this resistor, what is the voltage drop? 4 I3, right? Okay. Positive or negative? Positive or negative?
Positive.
Positive. Done. Next. As I flow around, is there one more resistor? Yes, there is one more resistor here. Now I want the voltage drop across this. What is the voltage drop? 2 I2. But is it going to be positive or negative?
It should be negative.
Negative.
In opposite direction.
Because it's in the opposite direction. So you get 3 equations. Is this fine? That's how you got minus 2I2. Is this fine? How to get the equations? Okay. Once you guys have the equations, you have to solve them. Now you could solve them by guessing. Can you guys guess here? Okay, here's the awesome part. If you were to solve them, I'll solve them, okay? I'll just add them and do something. Is that fine? You guys can try your own methods. You can put it in a calculator and solve it or any of that. If you solve it, you will get I2 is equal to 0. And you get I1 is equal to 5 and I3 is equal to 5. Did you guys solve this before? Okay, now here's a fun part. Did you guys see this? I2 was 0. Why? Why is I2 0?
There's current flowing in through the first loop, but then there is an opposite current.
But
flowing.
Basically it's saying the current through I2 is 0. Current through this resistor is 0. When does the current through a resistor 0? Tell me. Wheatstone's bridge, remember?
When there's a free space.
When there's
infinite
it's the same voltage on both sides.
Leave that. When is the current through a resistor 0? Ohm's law. Tell me.
Like-
When is
No
It has
potential
infinite
difference.
resistance.
when?
It has infinite resistance.
No.
No potential difference.
Normal resistor. For a normal resistor, yeah, Afsa is right. What is it? When the voltage is 0 across it. Remember? I have a question for you guys. What is the voltage here? 20 volts, right? What is the
20.
voltage? 20. What is the voltage here?
20.
20. What is the voltage here?
20.
20. What is the voltage here? 20. What is the voltage here?
20.
What is the voltage here? 20. It's the
20,
same
so
junction. What's the voltage here?
20.
What's the voltage across the resistor?
0 because
Done.
or 20.
I2 is 0. Voltage across this resistor is 0. Do you see that? Did you guys get that part?
Yes.
That's why no current flows through that. So if you had understood that part, you could have solved. So the point is, you don't have to even solve the problem. You look at it and realize that resistor is useless. What do you do when you find such a resistor? You throw it. Remember that? You throw it and solve the problem, usually. You didn't even have to deal with I2 if that was the case. It was a simple loop circuit. Okay. Did you guys get this? Get all of this? This is one problem I skipped, but always, okay, that's why I always do voltage analysis. Is that fine? Will you guys try that from next time? Always try voltage analysis. Try to figure out the voltages.
So
Okay.
shouldn't all the loop directions, the current loop directions be same?
No, there's no rule. You can do clockwise and anti-clockwise. You can one be anti-clockwise, another one be clockwise. Your call. Personally, I would recommend this, guys. Have you guys checked out Khan Academy's videos? Set of videos, Khan Academy. Guys?
No.
No, none of you check Khan Academy. I think they do a good job with Kirchhoff's laws. Khan Academy. I think they have a set of. Their method will be different, okay? Because Kirchhoff, you can have many this thing. You can check it out on your own, okay? There's KVL and KCL. They show you the applications, how to solve it, okay? Loops and all of that, which are very good.
Sir, do we need to use a VPN for that, or is it available in the Indian edition?
Do we need to
use a VPN for that? Because some of Khan Academy's work is geo-locked. So, for example,
I didn't know that.
To access pre-calculus,
use the
I need to
VPN.
use.
Yeah, use the VPN then. Others use a Tor browser. It's available, right? Tor browser. That'll work.
Yes, but Tor defaults to Switzerland or Germany, I think. So I think you have to use a VPN.
Oh, okay. Use a VPN. Yeah, that's fine. So the point is, yeah, just go through this. Okay, there are practice problems also, which will brush up your ideas a lot. Okay, this is the current junction rule and so on. The point is, it's college level physics what you're studying. Okay, it's not just high school level. This is much more harder. And yeah, DC circuits, under DC circuits, I think they might have the whole thing. Yeah, this is what I'm recommending: loop rule and the Kirchhoff thing. There are other rules out there, but for now, this is fine. Okay, this is fine. This is sufficient, more than sufficient. Yeah. Okay, yeah, that's the answer to the question: how to solve the Kirchhoff's this thing. Yeah. Anything else, guys? Questions are taken. I saw one video, but I'm not sure of it, but it uses differently. It uses sigma delta is equal to 0. Yeah, there are some other methods. The point is, the understanding is important, okay? I give you a method which you can translate other things. So I give you a method where you set the loop directions and so on. There they will try to analyze just using voltage. So there are many methods, okay? So it's an optional thing. And Kirchhoff's laws are like important, but you don't need to know the method if your understanding is sufficient. If you can use one of the methods, it's fine. You'll get the answer. And one more thing, if you're doing electrical engineering, you'll be using Kirchhoff's law every day. Okay, almost every day, because almost every problem will be Kirchhoff's law. Every problem, because there'll be transistors. Now you're doing voltage drop across resistors, right? In advanced engineering, in electrical engineering, you'll be finding what is that? Transistors, I don't know, capacitors. You'll have to do voltage drop across capacitors and so on. That's all. Okay, it gets complicated that way. And there'll be AC circuits and so on. So yeah, anyways, this year we won't be doing AC. Can we guess 2 ohm resistor was 0 in that question? The current through that resistor. Now you could not have guessed. You could not have guessed here. This was a little bit tricky. Okay. What you could have realized is that this is 0. That this is 0 because this end is at 20 volts and this end is at 20 volts. You could have analyzed it. You could not have guessed it, but you could have analyzed it. So you can make guesses, but it's going to be hard. Okay. Yeah. What is a transformer? I will answer that question when I do the 4th chapter, if I do it for you guys. Is that fine? Basically, it uses magnetic field to transfer energy. And then again, it converts energy from the electric field to the magnetic field, and then magnetic field to the electric field. That's a transformer. Okay, that's the simplest explanation I can give you. Transforms energy from one form to the other. Yeah, that's one simple way of looking at it. It uses coils to generate magnetic fields and it transfers in them. Yeah, I had explained it in class. Okay, awesome. Okay. Using different methods, do we get different? No, you won't get different answers. If you use different methods, the methods in the sense, there are different methods, right? The methods are the same. They use the same laws, Kirchhoff's laws. Is that fine? It's like this. Newton's equations are there, right? Newton's laws, first law, second law, third law. You can use your own methods to solve the Newton's problems, Newton's physics problems. But the underlying laws are important. Once you understand them, you don't have to struggle. Okay, that's the idea. You don't have to struggle once you understand the laws. That voltage drop and so on. Can you send this PPT? Oh yeah, this PPT is already available online. I think so. It should be available online. Some people have cracked it. I will let you know where it is. I'll tell you the password to it. 1 second. It's on my website. 1 second. Teaching and courses. It must be there. Okay. Okay. I'll just show you the link and I'll be done. Okay, we will have to close here because coronavirus curfew, so on. So 1 second, I'll have to close here. Where is 10th standard? 10th standard, 10th standard, 10th grade physics. It'll be under this list. Load, drive. Yeah, it's here. Okay, this one. This is the PPT. Is that fine? Awesome. The password is, it's not 1 2 3 4. This is the password. It's not 1 2 3 4. That's the password. Okay, to open the PPT. Now, if it won't work, then add apostrophe or remove the apostrophe, whatever one will work. Yeah, I did contribute. Okay, yeah, you can check out. Not contribute exactly. I made a recurring video based on that. We will discuss that in the next class. I'm really sorry. I'll have to go now. We will have to shut down things here at CFL. I am at CFL right now. Came running from my house. I told you that I was nicely sleeping. Then I was told your class exists and so on. Okay. No, just kidding. I wasn't sleeping. I was coding. Okay. Anyways, can we make a move? Is that fine, guys? Okay, I'm here. Can we make a move?
Yeah.
Sir, thank you, sir.
See you guys
Thank
some
you,
other
sir.
time. See you guys some other time. Is there anything
Thank
happening?
you, sir. Bye, sir.
Yeah, bye. Nothing happening.
Sir, there is supposed to be a class on next Monday.
Yeah, next
I
Monday there's
remember.
a class. There's a class. I think. Yeah. Good luck. Watch out for SN15. It's gonna fly probably. Nothing else. Yeah. Okay.
Thank you so much.
Yeah.
Bye,
Bye,
sir.
guys. Bye.
Thank you,
Bye.
sir.
Yeah. Bye.
Thank you, sir.
Thank you, sir.
Okay. See ya. Bye.